A very good morning. I'm Prasad Devre, Senior Director, Data Security Council of India. I welcome you on behalf of DSCI. I hope you enjoyed your sessions yesterday and are looking forward to exciting sessions today. Well, over the last 3 decades, the tech stack has evolved a lot. Old days there were mainframes, then there was client server technology, then web applications, then mobile apps, then came cloud transformation where you had hybrid, multi-cloud, cloud native applications. And similarly, the development methodologies evolved. It was waterfall, spiral, then agile way of developing softwares and applications, DevOps, DevSecOps. So today we are going to focus on integrating security automation within the CI/CD pipeline is to ensure confidence, quality, and assurance across the DevOps coding lifecycle. This workshop will demonstrate how your developers can secure their code during DevOps lifecycle. Without further ado, I would like to invite Vikas Rajpal and Govil Rajpal to deliver this workshop. Vikas heads the India and SAC Harmony business for Checkpoint, and Govil heads the security engineering for Checkpoint. Over to you, Vikas and Govil.
Good morning, everyone. I hope I'm audible. Thank you very much for your time, and it's a pleasure to be here. So I'll set the context maybe next 30 seconds why we have picked up this topic. So most of the customers, most of the CISOs I have met in last 1 or 2 months, their priority has changed. When we ask a question, what exactly they are doing in cyber security space. So one consistent answer that I'm getting from most of the CISOs is, how can we have cyber security by design? How can we secure application by design? So which led to this topic, how can we have zero trust? How can we infuse zero trust in the complete CI/CD pipeline? So in this workshop, maybe next 60 to 90 minutes, we'll speak about what are the security problems that application developers are facing. To be very precise, in cloud native application, what kind of security challenges ops team is facing when they deploy these applications in cloud native infrastructure. It may be serverless, it may be container, it may be VM, what kind of challenges these guys are facing. And the third one is information security team, CISOs. What kind of challenges they are facing when they have to monitor this entire pipeline when we say starting from code to cloud. So these are the three problems that we are trying to discuss in next 60 to 90 minutes. So I want this workshop to be very interactive. Please feel free to interrupt. Please feel free to ask questions. Please feel free to share your experience so that we can make it extremely interactive. So before we start the session, I want to ask a question. How many of you in this room are application developer who writes the code? No one?
Can you hear us? Perfect.
Okay. No one is application developer? Okay. So how many of you are?
But I'm sure you are consuming applications, which has been developed by somebody else, right?
So application run business today, right? So most of the customers are monetizing these applications. They are making money, right? They are running business because of these applications. How many of you are managing cloud infrastructure? Show of hands. Good. Okay. So you must be deploying these applications in containerized environment. You must be thinking of how to automate this so that we can have agile development in place. How many of you are from information security background? Yeah, so most of them are from information security background. So when it comes to application developers, they have become sprinters. They are moving very fast. When I say very fast, they manage to automate the complete application development pipeline, and there is no manual work these guys are doing today. So in case if they have to bring a new change in the application, they have to only write a code. They need to commit the code, and the moment they commit the code, it is basically deployed in cloud infrastructure in completely automated manner. Now, when it comes to information security team is kind of a jogger. We are running at very slow pace. We are not able to match the speed that application developer are running with. So when I say we are as an application security team or CISOs, we are very slow. So there are lack of tools which we are not able to keep pace up with, and that's the reason there is a gap which has been created, and we need technology which can help us to bridge that particular gap. Now, what is the outcome of this gap which is happening between application deployment as well as infrastructure monitoring and security monitoring? Unsecured software. That's an outcome. Outcome is unsecured software. A lot of vulnerable software which is coming out, and threat actors are taking advantage of those vulnerable software, and which led to the data breaches or cyber attacks. So Govil, can you speak about what are the cyber attacks which has led to?
I think multiple studies have been done in last 2-3 years. One Vikas mentioned, we have been speaking with multiple customers, how they are managing application development. Second, how they are managing, for example, their infra, where these applications are being deployed. And third, how CISOs, information security professionals, are managing security in that infrastructure. So this is one such study from ESG. So ESG says developers doesn't like security people because they are trying to create hurdles when they are trying to develop applications. Infra people are not liking developers, or I would say because of this automated infra which is there as part of cloud security infrastructure, that's where the misconfigurations have become very common. I was speaking to one of the customer. He said, I'm here in Delhi. Some of my teams are there in Romania. There is a business requirement to build a new dashboard to new product. Now, software developer, without knowing infra guy, without knowing security people, is trying to launch VMs, is trying to launch containers and trying to publish the code. So information security team does not have any visibility what infrastructure is being actually created on internet and how these applications are being deployed. So 43% of the cases, information security team has said, we do not have any visibility what is happening in my cloud infrastructure. 29% of the cases, we have seen developers are not liking to work with security people. And in case of 45%, software is released without going through security checks. So which means somebody is building a software, somebody is actually provisioning an infrastructure, and somebody is actually launching an application on internet, exposing an application on internet, and organization is not aware about it. But why people are doing this? Why this is happening? Why this fast development is happening? Because of strict deadlines. So another survey was being done with developers, with information security people and ops people, and that survey said organizations are taking that risk. So for example, 48% of the people says, yes, we do publish applications taking risk that there are vulnerabilities in the code. 46% cases. Then to meet the critical deadline with the plan to remediate in a later release, there are 54% of the cases. Then some people have said, we felt vulnerabilities had a very low risk, which means risk may be low today, but risk may be higher tomorrow. But still they are taking this call to push the code onto the internet for their customers, which has a known vulnerability. And sometimes these vulnerabilities were discovered too late in the cycle. So Vikas will discuss in another 15-20 minutes how the traditional CI/CD pipeline is working, why we are saying the vulnerabilities are being discovered at a later stage. So 10 years back, when I was working with my previous organization, development team was doing a development, and then there was a Nessus running at the end of the pipeline. In staging environment, we used to run Nessus, get a vulnerability assessment report, submit that to the project manager, and that's how the application was being actually published. There was no way to go back at the code level to fix those vulnerabilities, test it, run the scans again, and then do the deployment in the production infrastructure. Now the impact of this critical deadline is what we have seen in last couple of years, 4 problems. Number 1 problem is APIs are being exposed. It is like, will you share your password with someone by mistake? Will you ever do this? Let's say your Gmail password. Let's say your corporate password. Will you ever share your password with someone by mistake? But this silly mistake is happening in software development. Maybe Vikas, can you do a more clicks? Yes. So this silly mistake is happening in software development, which means developers are actually committing API keys, passwords, secrets, SSH keys, and they go to, let's say, publicly exposed versioning control tool, and that's how the database or the customer information getting breached. Another interesting thing we have seen in last couple of years is, maybe go back, which is supply chain attacks. Supply chain attacks are not new, and I will share a couple of interesting case studies here. How many of you have heard about CCleaner? Or you have used CCleaner? Perfect. So CCleaner was one utility on internet. We all were downloading that utility in the hope that this utility will clean my machine. What exactly happened one day back in 2016, 2017? Somebody did a backdooring to that CCleaner. 2.3 million people downloaded that binary in the hope my machine will get clear. But exactly what happened is 2.3 million people gets compromised on this planet. How many of you have heard about Target? So this whole story of supply chain attacks started from there. They had very interesting infrastructure, security at every layer, complete defense in depth architecture. So what threat actors did? They found out a vulnerability which is there in their heat and ventilation supplier. So target people were accessing an application from their heat and ventilation supplier who was actually doing management of their AC systems. They found out the vulnerability. From there they got into the target, and they were silent for 5 to 6 months because that malware was created specifically to capture credit card numbers. So there is one day in US when every citizen of US goes out for a shopping, and that is Christmas. And that malware got activated around Christmas time, and millions of credit card and debit card numbers were captured. And then we heard SolarWind saga around 2 years back. What was the problem statement in SolarWind? We have heard there was an intern with very weak password connecting to a VPN, password 123, okay? Another story says how we all got to know about SolarWind. So one day, one of the employee of a security organization found there are 2 mobile devices associated with 2-factor authentication profile, which is one is personal mobile and second is some other mobile device which he is not aware of. He reported that incident to information security team, and then information security team got to know, okay, there is something called SolarWind. But if you go deep into SolarWind reports, this problem is very, very, very complex to solve. And that is what we will be discussing in the next 60 minutes. And the problem statement is, you have a code which is clear text, human readable. Your developers can read that code. Information security team can read that code. And then you have a CI/CD pipeline which does build that code from human readable form to a machine understandable code. Now when you see a supply chain, the very first thing you will see is, what is the problem in my code? Code is completely clean. But the moment you go to the compiled version, which is a binary, rarest of the skill set on this planet, nobody will go and deassemble that binary to verify whether there is a backdoor in this binary or not. So which means something wrong has happened during this build process, starting from code, getting compiled, getting built, and then getting converted into a final binary version. Very interesting case study. There was a 40-year-old backdoor in C compiler. How many of you have worked on C before we move forward? Very good, couple of people. I used to do compilation of C code with a compiler. Now what compiler is doing? Compiler is taking my C code, compiling that information to a code which machine can understand. But have we ever checked what is there in that compiler code? No one. So there was a compiler in C, and this is a public data. It was actually unknown for 40 years. What that compiler was doing is, the moment you compile any authentication code which is written in C using that compiler was actually adding a OR operation to the authentication logic, which means check username and a password in the database, or username is equal to admin and password is super secret. Which means if you don't have username and a password, but you still know username is admin and password is super secret, you will be able to log into the applications. And that was not visible on the compiled version. That was not visible on the real source code. So these problems are very, very, very complex to solve. And that's where you need some sort of security checks which can be actually built in during the CI/CD pipeline. Can you go further? Now from the ops team perspective, you write a code. Now that code has to go somewhere and that code has to be actually executed in some infrastructure. 10 years back that infrastructure was servers, then VMs. Now we are running these codes into Docker images. From where these developers or ops teams are getting these images? Of course, Docker Hub. So they go to the Docker Hub and they download these images and then they start publishing their applications. There are 1 billion downloads for top 10 images in Docker Hub, and the number one is Nginx, which means every time you write a code for a web-based application, the base image you will always use is Nginx. If you are writing a code for a database application, the number one image you will always use is MongoDB. If you are writing something in Node.js, you will download that image from Docker Hub and then you will start customizing that image. We try to do a double click on these images. What is the current state of this image which developers and ops team is using to publish their applications? So this double click says, maybe go back. This double click says there are already 6 critical vulnerability in an image which we are trying to download and using it to publish my applications. There are 18 high severity vulnerabilities and there are 8 medium severity vulnerabilities, which means after running multiple tests, we have been able to identify the image which is there already on Docker Hub has certain vulnerability. May not be valid for a customer one, but maybe a valid vulnerability or a high risk vulnerability for customer two. But knowingly, unknowingly, what we are trying to do is we are trying to use these images and trying to publish our applications. Now taking all that into consideration, next, for the very first time in 2021, cloud attacks surpassed on-premise attacks. So there were 73% of the cases attacks were on cloud infrastructure versus on-premise infrastructure. And this report is again coming from Verizon Data Breach Investigation. So this data was published back in 2021 and they mentioned the attacks on cloud infrastructure is more. And I always say logic is simple, wherever users are, there the attacks will be. Office 365. Everybody is moving from Exchange to Office 365. And suddenly we have started seeing the number one phishing kit on internet is Office 365. Why? Microsoft published a report 6 months back. There are 300 million users using Office 365. That is the reason we have a lot of phishing attacks on Office 365. Same way, the moment COVID started in 2020, we all started moving our applications from on-prem to cloud. Whether we call it a digital transformation or cloud native application or cloud adoption, it can be public or private, but we all started using cloud. And the moment we all started using cloud, the very first thing we saw, I'm sure you all have heard it, SSH servers are exposed on internet. So people are using password exposed in breach 1 and trying to use the same password to log into your cloud infrastructures because they are exposed on internet. RDP machines were on internet. So people started using RDP machines. And again, end result was a lot of ransomware attacks. So we have seen a lot of attacks due to this adoption because we feel that misconception is still there because I have moved to the cloud, that security will come from the cloud provider. So we don't think about that shared responsibility model which we have to follow. So they are providing infrastructure, they are ensuring security of that infrastructure, but not the security of those applications. Yes, Vikas.
I think we can take a pause, and in case if you have any questions, then we can switch to the next section. Any questions so far?
Till now?
Do you have visibility into kind of images that is being downloaded by your ops team and whether those images are vulnerable or not? Do you have such practice in place? No? Okay. So why it is happening? So I think Govil has set the context. So there is a problem. Why this problem is happening and what exactly we have to do in order to fix this problem. Now over a period of time, if you look at the application development has evolved. It is no longer waterfall model wherein we need to plan, we need to build, we need to test, and then we need to think about security. The security is always an afterthought. So when it comes to application development, application deployment, once that application is developed, it is deployed either in cloud infrastructure or let's take an example, it's some monolithic application in your private cloud, we basically put security around that particular application because it has become now crown jewels because it is processing the data, it is storing the data, and the most of the security investments that organization has done, it would be around applications. So we deploy next generation firewalls, we deploy IPS, we deploy application security in order to protect that particular application. Now, what if in case if that application is already vulnerable, right? Because application developer has done some mistake, it may not be intentional, it may be unintentional, which will keep that particular application in vulnerable state. Now, today, you may have that false sense of feeling that your application is secure, but it is not. It is secure until any threat actor is not able to find that particular vulnerability until that vulnerability is not exploitable. So security is always afterthought. Now when it comes to cloud native application development, this has completely changed. When I say completely changed, this entire pipeline that you see, code, build, test, release, deploy, and operate, it is completely automated. So I'll give you one example. So let's take a scenario wherein we have application developer is trying to develop Java application. So they would be using some sort of development tools to write the code. The moment that code is written, it has to go to version control system. So let's take an example. That version control system is GitHub. The moment that code has been pushed to GitHub, then CI tool will come into picture to trigger the pipeline. So that CI tool may be Jenkins. Jenkins will talk to Maven. Maven will basically convert that particular code into artifact file. Now, once that artifact file is developed, now we need to deploy that application into environment. That environment can be a private cloud, it can be public cloud. If you're talking about cloud native application, it will be containerized application in most of the scenarios. Now, once that application is being deployed, so it may be pre-pod environment first. Once that pre-pod environment test passes, then it will go to production and we'll start monitoring the application behavior. We'll start monitoring how exactly application is performing in that particular environment. Now there is no security. Security is always afterthought. Yeah, there are few security checks, traditional security checks that most of the organization has. But when it comes to continuous security, continuous compliance, shifting security as early to the application development phase, that's where we see we need to find out where exactly the problems are. In case if we are able to find out problems as early in the development life cycle, we can basically secure the complete application life cycle. How we can do it? So the approach that we have, so most of the organizations are adopting the zero trust approach, wherein we put checks and balances at every stage when it comes to deploying the security. So if
I think maybe a question, how many of you have started zero trust journey around network access, for example, ZTNA? Because this is what we are doing. Many of us have started zero trust journey around authentication, right? Or MFA policies, right? Why not to start this zero trust journey around application development as well? Because the ultimate reason for a breach is application. This is which is happening. And if you see the ultimate reason for any ransomware attack, right? Whether it is a misconfiguration or a vulnerability or a 0-day, everything actually leads to a ransomware attack. So we have tried to follow this zero trust approach at multiple places, right? Around authentication, for example, around network application access. Why not to follow that same zero trust access here as part of your application development lifecycle?
So what we can do with this zero trust approach, at every stage in the pipeline, we can have some security checks introduced so that we are spotting all these vulnerabilities, we are spotting all the problems that we face during the application development lifecycle as early as we can, so that the end result that customers are getting, that application is more secure, number one, that application is operating in safe environment, and that application is continuously being monitored for all the security issues. So that's an outcome when it comes to having shift left security in the complete application lifecycle. That's where the journey is. In case if you have not started this journey, your application team must be thinking about this, how they can secure the complete application security, application development lifecycle. Now the outcome is, one, it will have a more secure code, and second, you can run fast as a security team, you can run as fast as your application developer. So it will not become, it will not basically become a breaker when it comes to implementing security in the application development lifecycle. So what are the problems that we are trying to fix when it comes to CI/CD security or the application, cloud native application security? At the developer level, most of the time, what they do, they basically do a static code analysis. That's a code review. I think most of you must have heard about that. The moment developer is writing a code, in case if we can give them a security tool which is as fast as they are, and that tool can spot the misconfiguration, that tool can spot the secrets, the tool can spot the API keys. Google spoke about how API keys led to massive data breach. So at the time of coding, at the time of application development, in case if we manage to find all these problems, we can fix those issues then and there. Now, moment the application has been deployed, now application has to go to your version control system. That version control system can be, example, GitHub. In case if we can have a tool which can scan the version control system for all the security problems, we can spot the problem then and there, and we can give a notification back to application developer, and we can solve those problems then and there. Now, once that problem is solved, application is ready, application is secure. Now we need to deploy that application, and we need to make sure that application is being deployed in secure environment. Application needs secure environment to run. So there are tools, there are technologies wherein we can find out whether the image that is being downloaded from, in order to build the container, whether that image is right or not, whether that image is vulnerable, or it is a legit image wherein we can build the container and we can run the application. And moment the application is deployed, now we need to make sure that application is operating in highly secure and compliant environment. So in case of cloud native, you may be using virtual machines, you may be using AKS, EKS. How can we have continuous compliance implemented so that we can monitor how exactly is application behaving in the compliant environment? Any questions?
I think maybe we can go to the previous slide and we can have a discussion. Any questions here? Why do you feel developer is exposing credentials? Intentional, accidental? Accidental. Very good. Why do you feel, after knowing the fact that image we are doing or using to publish the application is a vulnerable one, why we are doing this? Of course, developer will not take care of this. The job of developer is, as Vikas mentioned in his first slide, they are sprinters, right? They want to develop fast, they want to publish their code fast. But ops team says, or ops team is aware of the image they are providing, for example, for developers has a vulnerability. InfoSec team might be aware of, I'm not sure, might be aware of. In some cases I have seen they are aware of, in some cases they are not aware of. But why they are still using the same image?
there should be a mandate from the infosec team side that from to the ops team that whatever image you are using for containers, it should be updated, well updated, like what we are doing for the rest of the softwares.
Okay. So I think that's a problem. So most of us who are sitting in this room has access to the tools which address the shift right part of the cybersecurity, right? In case if you have tool with you, maybe you can spot whether the image is being downloaded from a repo which is not an authorized repo as per organization security policy. The image that we have downloaded has certain backdoors or vulnerabilities. In case if there is no tool, no platform that InfoSec team is using, they will not be able to monitor the problem which are happening in shift left, which is closer to the application development, closer to the application deployment. Now, when it comes to the KPIs of application developer, today the KPIs of application developer has changed. What is their KPI? Any guesses? They have to produce fast. They have to run fast. They have to build the code fast, right? Because this is where the business needs are. Now, when it comes to KPIs of InfoSec team, what is their KPIs? To secure the application, to reduce the risk. That's where the gap is. Now, in case if we can give a tool to InfoSec team wherein they can monitor the shift right as well as the shift left, they will have the complete visibility because a junior developer, his KPI is to develop fast. He will not be worried about the security. He will not give much time. He will not give focus on the cyber security, and he doesn't understand the nuances of cyber security.
Because there is a chat GPT. Junior developer will go to chat GPT,
Absolutely.
download the open source stuff, use it in the code, which means the end result is 70% of the code is copy and paste, and 30% of the code is actually their own code. That is the ultimate goal actually. That's how the applications are actually being published today. And maybe another interesting fact, because which we were discussing, why sprinters doesn't want to work with joggers and why joggers doesn't want to work with security people who are actually walkers. If you see the ratio in the CI/CD or development journey, it is 100 is to 10 is to 1, which means if there are 100 developers, there will be 10 ops guy and then there will be 1 security guy. So what they will try to do is they will actually try to bypass all the barricades which security team has put in. And this is what happening. Yes, sir.
So I have a question. Most of the security aspects, which may be secure DevOps or security in DevOps, mostly speak of the products off the pipeline in terms of what products or applications are developed off the pipeline. But very few touch upon the concept of for the pipeline, which is securing the pipeline itself. So can you share some thoughts on that?
So the next section of our talk would be how we can infuse the zero trust, how you can put the gates closer to the application development, gates which are around shift left, shift right, and how we can have a secure architecture in place, how we can have a platform in place which can give you the complete visibility starting from application development till the application is being deployed and running in your public or private cloud.
Yes.
Okay.
Any other questions before we go further to the next section of this talk? So we have discussed problems, right? Now let's move to the solution part. How exactly, as you have asked, how exactly we can infuse the security and how exactly we are doing this with the help of Checkpoint CloudGuard portfolio. Again, same traditional concept, defense in depth. This is what we have tried to do. The way we have done defense in depth in our data centers to secure applications, the same way defense in depth has to be there in cloud infrastructure as well, in CI/CD pipeline as well. We have divided that defense in depth infrastructure into these 5 gates. Gate number 1 is extreme deep shift left, and that extreme deep shift left is developer itself. What solutions we have on the developer machine itself, so that if developer is trying to do a accidental exposure of keys, secrets, how we can enforce the deterrent control for that developer. That you are not allowed, for example, or by mistake you are actually trying to expose the credentials. Gate number 2 comes the moment they publish the code to the versioning control system, and that goes to the CI/CD pipeline. And the moment that goes to the CI/CD pipeline, there are multiple controls like SCA, software composition analysis. This is what we will discuss. Then SAST, for example. Once it is there in pipeline, for example, and ready to be deployed, for example, in staging environment or production environment, how we can have workload protection. We have been discussing about vulnerable images. We have been discussing about a problem which is there in the code itself. So how this runtime protection will ensure vulnerable images should not go in production, and if they go, there should not be any code which has, let's say, SQL injection vulnerability or any OWASP vulnerability should go in a production. Gate number 4, specifically around information security people. I want to have clear visualization. How many accounts my team is using in cloud infrastructure, be it a single cloud or a multi-cloud? How many assets are currently onboarded? Out of that, where those assets are, how many vulnerabilities are, whether they are compliant from PCI DSS or HIPAA or GDPR or let's say NIST best practices. All that visualization you can bring in, be it a public cloud or private cloud or a multi-cloud infrastructure. And then last piece, when application gets into a production, how we can secure that application from, let's say, latest and greatest of OWASP vulnerabilities, exploit attempts which are happening. So we'll have a very brief introduction on these 5 gates, and we'll try to show you in a demo as well how exactly these gates are there as part of our CloudGuard platform.
So the outcome of all these gates and the security that we are trying to put, starting from application development to when the application run in cloud native infrastructure, you'll get a one single consolidated dashboard. That dashboard, from an InfoSec point of view, I would say it's an enterprise risk management wherein you can monitor end to end. You can monitor how exactly your application is being developed. You can monitor how your application is being deployed, and you can also check whether the application is running in a compliant environment or not. Example, fintech company, they follow a lot of regulatory requirements. We can check whether the infrastructure which has been provisioned to run that application is as per GDPR, PCI DSS or not. The infrastructure as a code, most of the operation team, they have automated how they deploy the application on the cloud infrastructure. Terraform templates that they are using, Ansible configuration files that they are using, whether those files, those templates are in line with GDPR, PCI DSS, or let's take an example, some other regulatory requirements. Is my cloud infrastructure is as per the best practice, NIST best practice, for example. So all these use cases you can do with the help of one single dashboard, one single platform. So that's an outcome of this zero trust journey when it comes to securing the complete life cycle. So we'll start with gate number 1, deep shift left. How can we secure the code? Now the problem that we are trying to address is developer does not like security tool. There is a reason, because security tools add the barriers. They make the entire journey very slow. So there is a need of a tool which is as fast as application developer are working. So we acquired a company called Spectral last year, and it's completely integrated into Checkpoint CloudGuard portfolio. What exactly Spectral is doing? It is helping application developer while they're writing the code to solve 3 problems. Number 1, secrets. When I say secret, it can be access token, it can be API keys, it can be SSH keys. So in case by mistake, unintentionally, in case some junior developer or developer has put sensitive information in the code, we can scan the runtime and we can give a notification back to the developer. In case if organization want to enforce the policy, we can integrate with the pre-commit hook. The moment they'll try to commit the code, we'll scan for all these misconfiguration and we'll make sure that code is not going to the merge into the repo. Now when it comes to scanning the code, the performance is key, right? We have almost 2000 plus detector. When I say detectors, you can customize these detectors, you can write your policies. Example, if customer want to search Aadhaar card inside the code, we can do that. That is also possible. And we can scan the code within 1 second. We did the testing, entire Linux code can be scanned within 7 seconds for all the security misconfiguration and all the security vulnerabilities. So we are not stopping application developer to write the code. We are not adding barrier. We are moving as fast as application developer is moving. Now the second problem that we are trying to solve is we do integrate in the pipeline. The Spectral tool is designed for developer. We do integrate with almost all the tool chain, DevOps tool chain that we have in order to make sure that the application life cycle is completely secured. There is no misconfiguration. There is no data leakage. Most of the time, what we do, we think data security or data leakage prevention from different points of view. We have email data leakage prevention solution in place. We have web DLP solution in place. Are we addressing the problem which is more serious as compared to the one that where we have invested the cyber security money? So when I say data leakage, sensitive content inside code can be scanned and we can make sure that there is no leakage of intellectual property outside your organization. So what else we can do? We can scan the Terraform template in case if operation team is using those templates to deploy application in public cloud, and we can also make sure whether those Terraform templates are compliant and they are in line to PCI DSS or they are in line to your GDPR compliance requirement.
Maybe a question before we move to the next stage, because there are some people from InfoSec background here. Let's say one developer somewhere sitting in some city or different part of the world has exposed secret, for example. How soon you will be able to get to know somebody has done a mistake? Let's say if you want to take one, I would say takeaway out of this session is try to do this simulation in your infrastructure. Somebody has committed a mistake, secret is exposed on internet. How fast you will be able to get to know there is something wrong on internet which can lead to a potential breach in my environment? Yes.
We have enabled dark web monitoring, so and we are monitoring the keywords, like 4 or 5 keywords. So as soon as the code is exposed, or if that code contains the keyword what we have added, so it will give us that alert within 24 hours.
So this is what I have got from multiple customers. We have a dark web monitoring tool which can crawl dark web, which can crawl clean web, for example, and the moment those keywords will match, then I will be able to get to know. So what Vikas was mentioning is we are not adding a barrier, for example. The moment somebody is exposing a secret, next minute you will have that information alert and incident created in the platform that somebody has done the damage. Rather than waiting for that web crawler to crawl entire dark web or internet and then coming back to you in 24 hours or 48 hours, and that too when you have those keywords getting matched with the secrets which are being exposed. Rather than waiting for that 48 hours, what if this platform is in real time giving you a information? Somebody has committed a mistake sitting in, let's say, Romania. They tried to commit a code in a versioning control system and that had a API key or SSH key. You can reach out to that person directly because you will be able to get that user information as well, developer information as well, and you can actually within minutes remove that API key or a secret from the publicly exposed cloud infrastructure.
That is actually the detective control and not the preventive control.
Yes,
absolutely.
Another challenge customers told us, okay, crawler is giving us that information, there is a secret somewhere. Now finding that person out of, let's say, 10,000 developers, right, is become a pain. It takes again couple of hours to identify that person, then reaching out to that person and then asking that person to remove that secret from the internet. So this can be done in matter of seconds, and you can actually take a call and you can actually decide whether this should be there on a publicly exposed infrastructure or not.
I think before we discuss step number 2, which is how we can improve the code quality when it comes to security, one more question I want to ask. What do you think who is the most privileged user you have in your organization? Most privileged user in your organization?
System admin.
Any other guesses? DBA. And who is responsible for data breaches? In case if there is a data breach in the organization, who will get the first call?
No.
Information security, CISO, right? CISO will get the call. Now the most privileged user in your organization today is DevOps team. They can do anything and everything without even your knowledge. They are spinning up instances in public cloud without your knowledge. You are not getting any visibility what they are doing, what kind of VMs they are spinning, what kind of applications they are running in those VMs, and what is the quality of that particular code. What is the security efficacy of that particular code. And who is responsible? Responsible is CISO. CISO will get the first call in case if there is a data breach because of that application which is not aligned to the cybersecurity best practice. That's the reason it is extremely important to change the mindset, to change the culture so that we can insert security at every gate, starting from application development to application deployment, code deployment. So that's where the step number 2 or gate number 2 comes into picture. How can we scan the code for malicious URLs, IP addresses, files while doing the integration with your CI tools. When I say CI tool is kind of an orchestrator which basically orchestrates the complete pipeline, and it's a bridge between continuous integration and continuous deployment. So Jenkins, I think you must have heard about Jenkins, right? Almost everyone in this room should have heard about Jenkins. How can we integrate security with CI tools so that we can scan all the functions, we can scan all the artifacts that is being generated, we can scan all the var files. When I say var file, it's an artifact file. We can compile all the, we can scan all the compiled software and the libraries for malicious IP address, malicious URLs, as well as for vulnerabilities. Very interesting study. Any idea how much percentage of the code is being written by application developer today? It has changed a lot. Any idea? 10%, absolutely. Only 10% of the code is being written by application developer, and 90% of the code is being reused by application developer, and they are using open source tool. Now these open source tool has access to third-party libraries. Now these libraries may be secure, it may not be secure. Who is the owner of those libraries? Who has done the development of those libraries? We don't know. Govil spoke about one example. You may have done the best job while writing your code, but there are few things which are not in your control because you have sourced the 90% of the code from outside your organization. That's where this tool will come into picture. We do software composition analysis. We understand how exactly this code is built, what kind of libraries that we have called in this particular code, and we scan all those libraries, import functions, and we give complete visibility, end-to-end visibility to CISO using this enterprise risk management dashboard. And you know what is the state of the application and whether this application is secured or not. So that's the gate number 2, software composition analysis. Very different from SAST tool, SAST. SAST only does scanning for the code that your organization or your application team has developed. So it reads the code, understand whether code has some SQL injection, cross-site scripting kind of application-based attack. But yeah, there is another tool that is required in order to augment the security, enhance the security, that is software composition analysis. I think industry is moving towards software bill of materials, SBOMs, wherein you can actually find out how exactly your code was built, what is the libraries you have, and whether those libraries are outdated libraries, vulnerable libraries, and in case if you have to upgrade those libraries to next version in order to fix those problems, you will have one single dashboard to see that.
And the best example is Log4j.
Log4j, yeah.
Right? That was not your problem. That was not your developer problem. But they wanted to run Apache. They wanted to use an application which runs on Apache, and you needed it Log4j libraries. What was the fundamental problem when Log4j came in? Friday evening. What was the fundamental problem? We all were aware via different security organizations, via different blogs. Okay, there is some problem. There is a library which is running in your Apache applications, and somebody can take advantage of this vulnerability. We all were not aware about the impact or scope of Log4j in my environment. I have 10,000 servers running Apache. Whether they are using vulnerable version of libraries or not, we were not aware of. What we all did, okay, speak to my, let's say, IPS vendor, give me a virtual patch so that I get a time to update my 10,000 servers. And knowingly, unknowingly, what we did, we upgraded all the 10,000 servers, Linux machines, running Apache, running Log4j, but could be a case, problem was only there in 100 machines, not rest of the 9,990 machines. What if you get that visibility on the console? So platform will give you that visibility on the console. Only 50 servers, this is the path, that's where in this row, in this line, you have actually used Log4j library, which is vulnerable for this specific vulnerability. Only fix these 10 machines, 50 machines, 500 machines, rather than actually focusing on 10,000 machines which are there in my infrastructure. Yes, sir. Sir, Vikas told about a couple of minutes back, we can scan entire kernel very first thing in 7 seconds, which means this tool can scan all the libraries which are being used during the CI/CD pipeline or in the Linux kernel in just 7 seconds. We will talk about another interesting gate in another 10 minutes, that is our web application and API protection. When you see the public reports, don't consider this is coming from, let's say, 2 people speaking about Checkpoint. There are public reports available. Our web API and web application and API protection solution was able to block all the Log4j exploit attempts 0 day without having any signatures. So that platform is completely signatureless, tested by multiple third-party security organizations. Have been done a lot of simulations on that platform, and these reports are public. So 0 day we have been able to block Log4j exploit attempts without having any update or signature in that specific platform. So all our customers were secured actually.
So to answer your question, so I'll add what Govil has said. So this can be done at code level. So in case if you're using Spectral platform that we have, you can write a custom detector and you can scan all the servers to find out whether the Log4j libraries are there in the code. That's a reactive way of doing it, because you got to know that there is a Log4j. Now you have signature in place. Now you are going back to your ops team or the application team and you are scanning all the servers. Can be extremely difficult. Now the second way of doing it is at runtime. When your application is running, do we have application security in place which is completely signatureless, which understand the behavior of the pattern, which understand the kind of communication which is happening from outside world, whether that communication is legit or malicious one. So we managed to block it preemptively using machine learning models that we have. Now for that, the application has to mature their machine learning model, then only we can do it. In case if it is not matured, there is a likelihood that we can also miss the attack. Entirely depends how we train the model. Completely based on supervised, unsupervised, we'll touch upon that. And the third one is, as an OEM, it is our responsibility how fast we can respond to these vulnerabilities, right? So we also came out with the patch within 24 hours, which, yeah, within 24 hours, we gave that patch to our customers and they deployed that patch on IPS technology that we have. So when it comes to Checkpoint, yep, agree with Govil, you can refer to public references wherein we are the fastest when it comes to responding to any severe vulnerability. So multiple places wherein we can prevent and detect the attack. So first was detection and then prevention. Any more questions? I requested that let's keep it interactive. Any more questions, please? In case if you have any question related to your use cases, if you are facing any challenges, you want to have discussion, maybe we can address that.
Irrespective of all the app, big client app, web-based application, 3T architecture, or a mobile application, iOS or Android, all of those are covered?
So there are 3 types of apps. One is monolithic application, right? The solution that I'm talking about is completely cloud native. We don't scan monolithic application, but yeah, in case if customer wants to scan secret inside monolithic code and they are using the tools which is very similar to cloud native, we can do it. Now when it comes to web-based application, legacy web-based application, we have application security and API security. Now for mobile, there is a different platform altogether that comes under Harmony, wherein we can insert the security in the application using SDK. Now the moment User will try to interact with the application. What we do, we basically scan whether that application is operating in safe environment or not, whether that application is operating on safe phone or not. So one use case is, so most of the BFSI and fintech companies, the one use case that we have implemented very recently for one of the very large bank, and that's for PSB, Punjab and Sindh Bank. You can download their banking application. The moment you click on that application will trigger the scan. Now what we are trying to do is, first use case is, we check whether there is a RAT tool on your phone or not, remote access tool, which can lead to fraudulent transactions. We can scan and we can give a notification back to the user, your phone is not safe for banking, online banking. Do you still want to continue? If they say yes, so we have now consent from consumer that he still want to do banking from phone which is infected phone, and we send that information to application. And there's a dashboard which is completely integrated with SIM, and they are able to get the information, the transaction came from device which is not a safe device to use. That's the first use case. Second use case that we have, if the mobile device is connected with rogue Wi-Fi device, example, you are at coffee shop, Starbucks. How do you know that Wi-Fi is from Starbucks? It can be somebody sitting outside Starbucks trying to mimic that it's a Starbucks Wi-Fi SSID. So what we can do, we can find out whether your mobile device is connected with rogue Wi-Fi, and again we can give the notification back to the user, you are not connected with the safe Wi-Fi network, and we can give an alert back to the. So yeah, solution is there, slightly different platform. We can do it for Android and iPhone based, iOS based applications.
Thank you.
Yep. So we can do a pre-hook commit, and you can define the policies. So in case if it is not aligned to the policies, we will basically block that particular. But the problem is developer has a power, they can basically ignore that particular configuration. So that's a major problem. That can be done. So I was talking about in case if developer is writing a code and he is trying to commit the code in GitLab or GitHub from his machine, will not be able to control. But yeah, scanning would be there. But there is a way to bypass it. That's the reason it is more of culture. They need to understand security. Security is how serious the security is. But for the second use case, we can do it because it is tightly integrated with the repo, and there are hooks wherein we can define those enforcement policies. So let me summarize what we have discussed so far. One, the gate number one was around how we can help developer to follow the secure coding practice. Second gate was around how we can integrate this entire platform to the CI/CD tools. And the third one is, now the code has been developed, artifacts has been compiled. Now application team will hand over this to operation team, and operation team has to deploy this. That's where workload protection will kick in.
So what I was referring earlier is, earlier this code was being deployed, let's say a physical server, on top of physical server there is an operating system running, and on top of operating system, let's say we are doing a deployment of the code. But now this code is being deployed because it is a microservice based architecture, for example. Now this code is being deployed onto containers. Now these containers are actually being managed with the help of, let's say, Kubernetes infrastructure for the orchestration. Now what exactly happens when application is being deployed? The very first thing is, we have been discussing from last 1 hour, is vulnerable version of image. So what we can do is, we can have a inside gate 3, we can have another gate, for example gate 3.1, which says, okay, I will check the image. If that image has got vulnerabilities, not allowed to publish the code. If image is safe, allowed to publish the code. And you can even fine tune that controls, which is admission controls, Okay, if there are medium and low vulnerabilities allowed, application can go ahead and application gets published on the container environment. What if it has got critical vulnerabilities? Not allowed, and that's where the pipeline will stop actually. So as an organizational policy, what you can do is you can decide whether you want to have a preventive measures during this deployment process or you want to have a detection measures as part of this deployment process. So detection measures means application will be published, container will be launched, people will be able to actually access the application and use the business logics, but you as an information security professional will get to know on the console, okay, application have been published, but it has got vulnerabilities. Now then you can take a call discussing with again dev people and ops people whether we want to take this risk or not. Second thing is, let's say now application is published. What we have seen in last couple of years, I'm sure you all have heard about is, sometimes people doesn't need any data from your infrastructure. They don't want to steal anything. What they want to do is they want to reuse your infrastructure to mine, for example, Bitcoins. So what they do is they will try to get inside that container, maybe due to a vulnerability, and then try to run their mining software so that they can mine all the Bitcoins and other things. The moment that gets into a container which is already in a running state, that's where the runtime protection comes in. Runtime protection will identify, okay, from last 10 days, these 4 processes were running which are actually serving users application. But now suddenly there is a new process and that was not there as part of the baseline. And the moment we see that new process, we can actually terminate that container and a new container can be installed, and that new container doesn't have, let's say, crypto miner installed. That's where the runtime protection is. Again, inside this workload protection, what we can do is we can onboard entire container infrastructure or Kubernetes infrastructure onto the platform to do the posture management. So you will be able to see how exactly the applications are being deployed, how many containers are running, and whether they are actually vulnerable to any vulnerabilities or not. So that's how the gate number 3 that will help you to do images checking, which is image assurance, admission control, so that only legit images goes to the production, and then runtime protection if somebody is trying to exploit the vulnerability and trying to, let's say, run the crypto miners in your Kubernetes environment. So that's how the gate number 3 will act, which is more around runtime security and admission controls.
Now the last gate is around posture management. Application is up and running. It is running in cloud infrastructure, cloud environment. How we can ensure that the cloud infrastructure is compliant and it is highly secure. So that's where the CSPM comes into picture, cloud security posture management. The first use case is we'll give you the entire visibility of what kind of cloud accounts you have in your organization. You have 1, 2, 30, 40, and what exactly, how many assets every cloud account has. Now once we'll give that visibility, you can also see the assets based on the category. It may be EC2 instance, it may be, let's take an example, security group. So we'll categorize all the cloud assets and you should have a single dashboard, unified dashboard to visualize all the multi-cloud strategy that your organization may have followed. So you may have application server in AWS, your database server might be in Google, so we can give you one single dashboard to monitor all the cloud assets using this cloud security posture management. Now once you have the complete visibility around what you have in cloud, the next step is posture management. So what you can do, we have predefined templates for all the regulatory requirements that most of the organizations are follows. So you can select those templates and you can run those templates against the cloud asset or the cloud account that you have. Extremely fast, in real time, you'll get to know how compliant you are when it comes to example GDPR or PCI DSS, and then you can also trigger the remediation action. Completely automated manner. So Checkpoint does support cloud bots. So you can either use the predefined bots which are there for remediation function, or you can customize it based on your requirement. This platform is very tightly integrated with Threat Cloud that we have. When we say Threat Cloud, one of the largest threat intelligence database, since we are collecting data from network sensors, endpoint sensors, email security solution that we have. So we bring a lot of telemetry wherein we can contextualize the information for you, and we can give you risk management dashboard so that you can see. I'll give you one use case. Example, your DevOps team has launched database server, and by mistake, the database server is exposed to internet because they have done the wrong security group configuration. Now the traffic is coming from outside, so we can give a contextualization wherein you can see whether the IP address from which the traffic is being generated belongs to Tor network. Is it a malicious IP address? And we'll give the complete visualization that this database server is completely exposed to internet. So that would be also visible in enterprise risk management dashboard that we have. Now, one of the key differentiators that we bring is the language that we have in order to ensure that your cloud infrastructure is compliant. You can write your custom rules. Extremely, extremely easy. Anyone in this room, it's an English-like language. If you understand cloud terminology, you can write best practices by yourself.
I think maybe I will take 30 seconds here. How many of you in this room knows English?
Everyone.
Everyone. How many of you knows Russian? Not one. How many of you use or know German, for example? So differentiator is, for example, okay, a couple of people, German. So differentiator is that language which Vikas is referring to, GSL, because every cloud security platform you see is a combination of multiple platforms or multiple acquisitions for any security company. The moment they bring all these platforms together, platform 1 is actually able to understand English, platform 2 can understand Russian, and platform 3 can understand actually German. So technically, if you want to do any customization, you need to actually understand 3 different languages. The beauty of the platform here is all the acquisitions we have done, all the integrations we have done, they are actually speaking one single common language, which is GSL, which is a kind of a very much kind of a English speaking like a language. You can actually, whatever you speak in English, you can write it on the platform and you will be able to actually get the desired results, irrespective of actually asking questions in 3 different languages. So this is the beauty of the platform actually with GSL.
So the last gate is around application and API protection. So recently acquired a company called ForceNock, completely signatureless application security platform. When I say application security platform, it basically secure all the web-based application as well as the API infrastructure that we have. So the technology behind under the hood that we are using is combination of supervised language as well as unsupervised language. When I say supervised, the model is pre-trained. The moment you will onboard your web-based application and APIs, it will give you the default protection against OWASP top 10. Now we need to understand the behavior of the application by monitoring the transactions which are happening in your environment. And you will actually see that machine learning model is getting trained from kindergarten to PhD. You will see that progression which is going on. The moment we will reach to PhD level, we will completely lock down the application. So when we say lock down the application, we have understood the behavior of the application. We have understood what should be allowed, what is the minimum baseline. Any deviation from this baseline, we will detect and we will prevent it. That's why we managed to prevent log4j preemptively without any signature requirement. Now another use case in cloud native world we see is application is changing at very rapid pace. And your application security is as good as your configuration of the application security firewall. I'll take a very crude example. Your application has 10 pages. You have done the configuration to secure those 10 pages. Now tomorrow, developer has added new capability. Now the pages are 50. You have added 40 additional pages. How about security for those 40 pages, new pages, 40 new entry points? So in case of conventional application security, you have to tune the policies. Somebody has to tune the policy to make it work for 50 pages. So what this platform will do, it will detect that there is a traffic which is coming on new 40 pages. It will again start from kindergarten. It will start giving you basic protection using supervised engine that we are using. And it will also start learning the pattern of the traffic for those new 40 pages. And it will adapt automatically. The moment we'll see the traffic on new entry point, it will adapt those changes. So auto-adaptive when it comes to defining the security policies. In fact, it's a zero touch when it comes to WAF security policies. You need to onboard the application and you need to forget. When I say you need to forget, you can basically see the progress, how the engines are getting mature and how this platform is giving you the protection. Another use case is very tightly integrated with Nginx, very tightly integrated with, in case if you are using Kubernetes, so we can deploy this as a ingress controller as well. So that's a last gate in our application security journey. So what we will do now, I'll give you the summary, what exactly we have discussed. So these are the guards we spoke about. So we can do static code analysis, infrastructure as a code scanning. We can scan your code for the secrets, API tokens, misconfiguration. Then we can do an artifact scanning using Spectral tool that we spoke about. The moment application is being deployed in cloud infrastructure environment, what we can do a container security. So Govil spoke about image assurance use case. Govil spoke about runtime protection. That's where we do security at runtime. And at last, we can give the platform wherein you can monitor what is happening in your cloud, starting from application development to application deployment. And the platform that we have for this end-to-end security is Checkpoint CloudGuard. Secure the cloud with unified cloud native platform, irrespective whether you're using private cloud, public cloud, you are on multi-cloud journey, hybrid cloud journey. So one single platform to give you complete visibility end-to-end, starting from application development to application deployment. So in next 10 minutes, so we'll give you very high level overview of the platform.
I think we can take maybe 10 minutes question and
Yeah.
then we have a Kahoot as well for 10 minutes, right? Yes.
First Kahoot.
Right, we can do Kahoot first.
And then?
Because already 18 minutes left,
Yeah.
so we can take questions and then Kahoot.
Any questions?
Can you brief about the framework supported for static analysis? Because there's a lot of new things coming up, right? And open source projects or even projects like SemGrep does not cover everything. So I'm trying to understand if you cover all the frameworks that are at least there in the market now.
So most of the frameworks are covered, and what we do, we basically scan the code for secrets. We scan the code for sensitive information. Those sensitive information could be, let's take an example, Aadhaar card. It may be PI information. And in case if it is not there, what you can do, you can customize. You can create your own detector. It's a YAML file. You can create the regular expression and you can scan it. And we also do software composition analysis. So let's take an example. If you're building a code and you are taking reference from third-party libraries, you're importing a lot of functions, we can decompose and we can check their CVs and we can give all the vulnerability status in one single dashboard. Does it answer your question?
We'll discuss this further.
Yeah, okay. Yeah, go ahead. So that's the platform, network security. So in case if you are doing lift and shift, if you want to extend the network security control that you have in your private data center to public cloud, so the same security that we deploy for our customer who are using on-prem infrastructure, same security can be extended to public cloud. Public cloud can be AWS, Azure, GCP or Oracle. Then we have posture management. Posture management will give you end-to-end visibility and will give you enterprise risk management and a dashboard wherein you can check whether your cloud infrastructure is compliant as per the regulatory requirement. Third one is workload protection. Will give you runtime protection, irrespective whether you are using containers, you are running your application in VM, or in case if your application is running in serverless architecture, that is also covered. So it was not covered in the slide, but yeah, it is already there. Then we have web application and API protection we spoke about, and the last one is threat intelligence and threat hunting. So threat intelligence and threat hunting is one single dashboard which will collect the information from all these modules as well as from the cloud platform, enrich that particular information, and it will give you one single unified dashboard for the context-wise risk management and risk mitigation. So that's the complete platform about Checkpoint CloudGuard.
So I need 2 minutes to set up Kahoot. Maybe in parallel you can take a couple of questions.
Any questions? So this was at very high level. In case if you need any deep dive workshop, please reach out to us. We can do a workshop and we can help you with your cloud adoption journey, cloud security journey. And it's typically 3 to 4 hour workshop wherein we cover the deep technical aspects of how exactly we are helping customer to move from on-prem infrastructure to cloud infrastructure, how we are helping them in their digital transformation journey.
Perfect. Next, maybe 5-7 minutes. A short quiz on what we have spoken in last 60-70 minutes. So you can actually go to kahoot.it and then log in with the spin 6309489. And we do have exciting prizes for top 3 winners. How the quiz will start. So you will see a question and you will see 4 answers in 4 different colors. But on your screen, you will only see 4 colors. So you have to choose the right color. And it is fastest finger first. Shall we start? 28.
Let's wait for 2 more seconds.
Okay.
1, 2.
Let's reach to 30 maybe then.
Yeah. I think we can start.
Perfect. Okay. So very easy questions. In fact, the first one is the easiest one, I would say. What were the names of today's speakers?
First option is Sundar Manish, second is Govil and Vikas, third is Amol and Govil, last one is Vikas and Amol. So you need to hit the right color.
Perfect. 19 of you have said Govil and Vikas. Maybe one has said Sundar and Manish. Maybe you have joined late.
Late, absolutely.
Right? Or 4 of you have said Vikas and Amol. Here is Amol. So Yagnesh,
Yagnesh.
fastest finger first, then Nayak, and then who is D?
Okay, okay.
Which year, as per Verizon, cloud security attacks surpassed on-prem attacks? This was discussed in initial 15-20 minutes. Perfect. 11 of you out of 28, 29 have said, because 2021 is the year when Verizon published their report, data breach investigation report, and they said cloud security attacks has surpassed on-prem attacks. Some of you have said 2023, 2018, and 2019. But let's see who is leading. Okay, Nayak, NP, Anurag, Mayur, and Shiva. So you are in top 5. Let's move to the next one. Which tool is used in CI/CD pipeline to scan third-party libraries? SCA, IDE, SAST, or DEST?
Software composition analysis, IDE tools, these are the plugins. SAST, static code review, DAST is at runtime. If you don't know the answer, hit the favorite color.
11 of you have said SCA, which is the right answer. IDE, SAST, and DAST are being used in different stages. Let's see. Okay, so Mayur is on the top, Shiva is on second, and Nayak. Let's go to the next one. It was there in slide number 3. How much percentage of developers do not like to work with security teams as per ESG report? Done already? Okay.
Only
the right
3,
answer
correct
is only
answer.
3, 29%. So 29% of the developers, as per ESG report, doesn't like to work with security teams.
So it was a favorite color or you knew the answer?
change.
Good.
Mayur is now on the top. And let's move. What was Sachin's score in his last one-day international match? Non-technical. Not related to CI/CD pipeline. Difficult one. 7 seconds, 6. Four of you have said right, which is 52. I'm sure this might change the score. Yes. Who is PD? You are not allowed. So, Mol, you should not stand next to him actually.
So PD, it was a guess or you love cricket? Huh?
No, he was
You
with us
know.
actually when we were creating these
Acha, okay.
questions. How many gate steps have been discussed during this session to secure the code to cloud journey?
Easiest one.
Easiest one, yes. We have discussed this in last 15 minutes. Still 19 of you, but one has said 14, then 7 of you have said 4, and even one has said 3 gates. Who is that? We can get the audit logs actually after this quiz and we can identify. Again change. What happened? Last 4 questions. How much time checkpoint code scanner? Okay, how much time checkpoint code scanner to scan an entire Linux kernel?
So I'll give you the hint. We are the fastest when it comes to scanning the code.
Wow.
Oh,
great.
still.
But still
Three wrong
better.
answers.
Still better. 24 people have said right.
Still 5 wrong answers.
Who is Sagar? Which technology is being used in CloudGuard portfolio to automatically remediate potential compliance issues? Vikas mentioned in his posture management gate, gate number 4.
Automation around remediation.
Remediations.
Easiest question to answer.
Seven of you have said right, which is cloud bots, and cloud bots can be used to do the automated remediation in case your environment is not compliant. Sagar is still leading, then Mayur, Nayak, no change in the position. I think last 3.
Last two.
Last 2, okay, last 2. Which tools offer configuration management capability to automate the application deployment? Okay.
That would be the tough one.
Automate application deployment. Perfect. 9 of you have said Ansible, which is the right answer. Good. So Maven is to build the code, Nagios is to monitor the application, Slack is to actually send out the notifications, and Ansible is being used to do the configuration management while automating application deployment. Last one. And okay, there is a change now, but Sagar is still leading. And I think you are the winner, Sagar. Which platform and checkpoint can help to secure cloud native application? The easiest one, fast. 6, 10, 15, yes. 5 minutes left. Twenty-four of you have said it right, which is CloudGuard. So let's see who is leading now. Number 3. Shiva. Who is Shiva?
Shiva, please come.
Please come on the stage.
Yeah.
Then PD. Okay. And then Sagar.
Amol, come. Amol.
Come.